So 3.5 is deriving trig functions.
Oh my gosh, my mom. Why do you always gotta put trig in everything? Yeah. Like derivatives was already a little hard, and now we got to put trig.
So the good news about today is that this is going to be basically like memorizing details. Okay, so it's going to be easier than the last time where you had to kind of understand what they were asking you to do. Now you just have to remember that the derivative of sine is this, or the derivative of cosine is that.
Are they like the
are we done doing this stuff?
No, I still have to test you on that.
Okay, but we're done learning it.
Okay.
Okay.
All right, so this right here takes you through the definition of a derivative and proves to you that the derivative of sine is simply cosine.
What's this called?
Derivative of trig functions. So what I would do is in your notes, you're just going to write down all these derivative notations. So we're going to have the derivative of sine is equal to cosine. I would write that down. Derivative of sine is cosine.
So it's the same equation. So cosine equals sine.
Almost. Not exactly though. Did you write it down? Okay, let's do a quick example.
So like sine and cosine, like x and y, the opposites.
Kinda. A little bit. You know how they're similar. Come on, this isn't rocket science. I said it like 8 times. Derivative of sine is cosine. Alright, number 1. Okay, so let's see if you can derive this. Let's say the directions say derive. Derive. Okay, so I'm just using like basic derivative methods for this one. What is the derivative of x squared?
Minus cosine x.
Look at that.
Yeah, but then the homework is always like impossible.
Oh. Okay, let's make it a little bit harder. Maybe like the homework.
Yes.
Okay, let's try B. How would you derive? No. Yeah, that was it. You gotta pay attention. Don't look away for a second.
Is it e cosine?
Okay, so on this one, I have 2 x's involved. Okay, so which method? I have 3 methods of deriving right now. I have basic rule, product rule, and quotient rule.
Basic rule. No, product rule.
I have to do a product rule on this one. You see I have a first and I have a second.
Oh.
Okay, so this is simply a firsty second plus secondy first.
Yeah.
All right, ready? Okay, so what's my first?
EX.
That's why you don't put your feet on the table there, Mike. That'd be great. Okay, firsty second. What's the derivative of sine?
Cosine.
Yeah, look at that. Cosine. Okay, plus my second. What's the second?
Derivative of e?
Sine. Ooh, good question. What is the derivative of e? Anybody remember?
E.
It's e to the x. Yeah, you wrote that down in one of your last sections. They just threw it in there randomly, so there you go. So this is simply e to the x cosine plus the sine. Well, actually, I probably would put this in the front. E to the x times the sine of x. Done. I heard easy. All right, let's try C.
Quotient rule.
Okay, so we have 2 x's involved. We have a fraction. Okay, we are going to use the quotient rule. So who remembers how the quotient rule goes? Ho-de high minus high-de ho over the ho squared. Okay, so what is my ho? We always start with the ho. X. Okay, so it goes ho-de high. What's the derivative of the high? Cosine of x. Minus the high.
Wait, why'd you put cosine?
Because derivative of the high. D ho minus, or what's the derivative of the ho? 1. All over the ho squared. High d ho.
All over what?
All over the ho squared.
Just remember that.
So this doesn't require much simplification. We could say x cosines of x minus the sine of x over x squared. Good so far? All right. Okay, here comes the derivative of...
Wait, go back. I'll write it down because
So anybody want to make an educated guess about the derivative of cosine?
It's gonna be sine.
Ooh, good guess. There is a sine involved,
Whatever sine.
but
Sine
it is
squared.
simply
Sine squared. It's gotta be sine squared.
negative sine. Write that down. Derivative of cosine is negative sine. Derivative of cosine is negative sine. Okay, ready for an example? Okay, let's try this one. Again, we are deriving. Okay, how would I derive this question?
You would.
What is the derivative of 5e to the x?
It's gonna be.
5e to the x.
Are you guys kidding me?
Because the derivative of e to the x is e to the x, so you just multiply that by
I
5.
think that's wrong. I think
Wait,
repeat that.
The derivative of 5e to the x is 5e to the x. Because the derivative of e to the x is e to the x.
I think it's.
So you just multiply that by 5.
I think it's gonna be 5x. E.
Is this the x and the exponent?
Yeah, the x.
5x. Because you don't multiply, it's not the same as an x in the exponent. That's a whole different ball game when you start deriving exponential pieces where you have an x in the exponent. It's not the same as the basic rule. It's
You
different.
can't do us like this.
We haven't got to
You
that
can't
yet.
tell us something and it's wrong.
we know.
I didn't tell you anything wrong.
Plus negative cosine.
Okay, so plus the derivative of cosine, which is can I just go ahead and say minus sine?
And it's done.
That's done.
Oh my god. Yeah, the homework you're gonna make me do that.
All right. So, do you remember all those trig rules that we worked with before? Oh, so here's an example. I'm not going to go through this example, but just so you understand why they start using sine and cosine. So, I actually remember studying this in college. Harmonic motion. Okay, so do you guys remember when we first learned sine and cosine, and I told you it can describe a sound wave?
Yes.
Okay, well, you can use that sound wave to analyze velocity and acceleration for harmonic. It also comes into like waves in the ocean, that kind of thing with, what are those things? Tsunamis. Okay, so they use that kind of calculus to analyze those kinds of equations. So just remember, this is very simple. Okay, if they give you a position equation such as 5 cosines of t, how do you go from the position to the velocity?
Derivative.
You just derive it.
Oh my gosh.
That's it. And if you have to go from the velocity to acceleration, say the same thing again. You just derive that.
Oh my god. 2 for 2.
That's it. All right. All right, so do you remember these 4 things? Okay, you should already have this written down. This is not new information. You learned about this last year. We know that tangent is sine over cosine.
Cotangent is cosine.
And all those
and
reciprocal
secant
identities.
is 1 over cosine. And cosecant is 1 over sine.
Exactly. So you can use those equations to potentially simplify a function before you derive it and make it simpler. Okay, you can turn things into sines and cosines as opposed to using the other trig functions. Okay, but sometimes it's easier to just derive the other 3 or the other 4. Okay, so your last 4 are right here.
Oh my gosh.
Yes, absolutely. Write these down.
Answers.
Absolutely not.
Write this down in your notes. Write it down. Write it down. Write it down.
What are these called? Just references?
You can't use that on a test.
Yeah, well, I'll write it down someday when I bring my notebook.
Hopefully you have that on Friday because you got a quiz on Friday.
No, we don't have. We don't have class on Friday.
We have it next Monday.
Oh yeah. That's
Have
right.
this note.
She'll give it to us.
Just right now, 10.
I don't have it made yet.
Oh, okay. Yes. Was. Wait, she can give us a. Okay, shut up. She won't do that.
Wow.
I haven't made it though.
Make it easy. Make it like 5
Okay, so as you guys are writing this, note to self.
Not self.
Okay, here's one thing that I always remember. So do you notice that tangent and secant are kind of like directly related between the derivatives?
Yeah.
Tangent is just secant squared, and secant is secant times tangent. Same idea with these two functions that start with the letter C. Ah, okay, so I always remember that the two functions that start with the letter C are related. Also, every function that starts with the letter C, what's the very first thing? Negative.
Negative. Oh my
They are
gosh,
all
negative.
negative. All of them are negative.
Oh my god.
Right? Okay. Tell me when you're done. Let's do an example. Let's do the hardest one I can find.
Yeah.
You ready?
No.
Let's do it.
No. That's not even a real equation. You say stuff I guess I should say
Are you guys done?
Yeah.
Okay. Okay, go. All right, number 15. Okay, so if I'm going to derive this question, how would I go about doing it?
You would start with.
Okay, we can do a product rule right here. I have a first and I have a second, right? So I can do a product rule. First d second plus second d first. Okay, ready for this?
No.
Give yourself some room because it's going to be long. Okay, we're going to start with the first. What's my first quantity? Secant plus tangent, good. Okay, now I'm going to go d second. So now I'm going to derive my second. What is the derivative of secant? Good. Secant tangent minus the derivative of tangent minus secant squared. Okay. Plus my second quantity. What's my second quantity? Secant minus tangent d first. Now I derive my first quantity. What is the derivative of secant? Secant tangent
Wow, this is ridiculous.
plus the derivative of tangent. Derivative of tangent plus secant squared. Okay, so look, you guys just derived that.
Yeah.
We can stop there. Now, here's the thing. This can be simplified.
No. Wait, you can take out a secant. No, what do you do? Actually, credit. Okay, I'm gonna need that.
Okay, so I'll give you extra credit if you can simplify this correctly.
Right now?
Okay, I'm going to give you extra credit if you can simplify both question 15 and 21. If you can do both correctly, I'll give you a +5 for your homework scores.
On just these two?
Oh,
Just
I really
these two?
need that.
Yeah.
You got me there.
Got you interested? So you'll have to FOIL it, yep. And it is also important for you to do this. You have to remember your Pythagorean identities.
Wow, this is so much fun.
Do you remember your Pythagorean identities? If you don't remember them, you can
It's,
either Google them or
cosine
look in your
squared
notes.
plus Sine squared equals, equals
Yeah, there's
1
3 of them.
equals 1.
There's 3 of them.
And did you hear that one? Sine squared plus cosine squared equals 1.
Yep, that's the first one.
Are you gonna write it down? Or?
Nope. It's extra credit. Okay, how do I do number 21?
Quotient rule.
Quotient rule. I have a top, I have a bottom. Okay, this time I have a t involved, so it's just going to be a ho-de high minus hi-de ho. Over a ho squared. All right, you ready? All right, so we start with the ho. What's my ho?
What is that?
1 minus, what is what?
Your 5? Is that 5?
That's a s.
Oh.
See how it has an S there?
I just was so confused because I didn't know there was an S.
It says a S right there.
I just can't see super.
Oh, you should get glasses.
I should.
Alright, D high. What is my derivative of 1 plus cosecant?
When I don't have basketball.
What is the derivative of cosecant?
Negative cosecant.
Oh my gosh, I can't write. Sorry guys, you'll have to finish this one. There we go. Negative cosecant times cotangent. Okay, then it goes minus my high. What's my high?
I like using X's because it stresses me out with the T's.
Feel free. Not that you're writing anything down anyways, but. D ho.
His T's look like pluses sometimes.
That's why I curl my T's. D ho, what's my derivative of my ho? What's derivative of 1 minus cosecant? Okay, so do you see how it's a minus, right? So it turns into a plus. Come on. Cosecant. Cotangent. What's that? No, because it's one term. It's kind of like x times y. Okay, and then this is all going to be over your ho squared. Okay, so I'm going to stop there, and if you can simplify that, it is worth extra credit.
Do you have to use conjugates or no? Can you just tell me if I have to use conjugates?
A conjugate is if there is a square root involved. I don't see a square root, so I'm going with a no.
I knew that. I just need that.
All right, so I think I've distributed this into your OneNotes, but your assignment is 2 through 44. It's actually not 65 at the bottom, it's 63 there at the bottom. So I kind of shoved that in there. So that's your homework. So you guys still have about a good 45 minutes. So I highly suggest you use your time wisely here to ask questions.
Thank you, Miss Nancy, for that.
Are you only saying that because I'm recording this?
Wait, what did it happen?